Hi, everybody, and welcome to Echo Live, coming to you from the Michigan Science Center's Echo Distance Learning Program. Today, we are taking another tour in our virtual planetarium. We've got a pretty special program planned with the help of our staff astronomer and NASA Solar System Ambassador, Paulette. So, hi, Paulette, how are you doing today?
I'm good.
Thanks for joining
everyone.
us. So everybody who's joining us on our multiple platforms, if you are tuning in through Zoom, YouTube, or Facebook Live, go ahead and introduce yourself in the comments or the chat feature. You can ask Paulette as we take our tour through our virtual planetarium. You can ask her questions in the chat. We'll keep an eye on those features throughout the program and save some time at the end to answer all of your space-related questions. Now, Paulette, I know we've got a pretty exciting program plan today to talk about something pretty specific. So with that, I'll let you take it away.
Yeah, so today we are going to talk about two of our nearest neighbors. We're going to talk about Mercury and Venus, the first two planets in our solar system. So you might have seen our little celestial buddies make their appearance on our Facebook page this morning, and they're here with me today to help me out with our program. So let's go ahead and switch over to our virtual planetarium so that we can take a look at what we can see. So we are now in our sort of spaceship of the imagination. So actually, let me do one quick thing here. There we go. That should show up a little bit better. So we're going to be in our spaceship of the imagination, and we're going to fly to our planets in our solar system. Now, before we do that, we wanted to take a quick look at our solar system. We have, of course, the sun, our nearest star right here in the center. Then we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So those are the planets that we have in our solar system. And like I said, today we're really going to focus on Mercury and Venus. So let's go ahead and in our virtual planetarium, head to Mercury. There we go. So let's go ahead and fly in to Mercury and take a much closer look. Now, we've been really lucky to have sent spacecraft to Mercury, the spacecraft called Messenger, and Messenger has been able to give us some really nice high resolution images. All right. So I'm going to try not to move as much as possible because I do know that it can sometimes be a little bit glitchy, especially because I'm using a planetarium software called OpenSpace, and that OpenSpace takes a lot of my computer's resources. So I'll try to keep the movement to sort of a minimum. But we have here the planet Mercury. Now, what else in our solar system does this maybe look like? What do you think? What else might Mercury look like in our solar system? If you have an idea what Mercury might look like also in our solar system, go ahead and type it in the chat. And again, what does Mercury look like? It's gray. It's got a lot of these spots on the surface. Someone says it looks a lot like our moon because it has all of those craters or spots. Exactly. So we do have a lot of craters or spots here on the surface of Mercury. And that's because Mercury does not have much of an atmosphere. So it doesn't have very much air along the surface. So there's really nothing to protect it from getting bombarded by small asteroids or comets. And there's no erosion or weather to wear away those craters. So much like our moon, Mercury is a very dry and rocky place. Now, somebody asked me, why is Mercury gray? And that's a really, really fantastic question. Mercury is gray mostly because of the rocks that it's made out of. And it's made out of a lot of things that are very similar to what our moon is made out of, which is why it looks a lot like the moon. It's actually much smaller than the moon. Mercury is about a sixth of the size of the Earth, and our moon is only a quarter of the size of the Earth. So Mercury is even smaller. It also has a temperature on the daytime side. So the side that we're facing right here, that temperature gets to about 600 degrees Fahrenheit. So the daytime side of Mercury is very, very hot. It also, on the nighttime side, can get very, very cold. Because there is not much of an atmosphere, it doesn't hold in that temperature or that heat. And so the nighttime side can actually get to about -200 degrees Fahrenheit. So very, very cold on the nighttime side of Mercury. It orbits around the sun every 58 days, and it rotates on its axis every 88 days. So that means that a day on Mercury is actually longer than its year. It does go around the sun very, very quickly. So here we have our planet Mercury. Now, what I'm going to do is I'm actually going to make it so that it's not shaded anymore. So we don't have any of our we don't have any of our sunlight on it. And I want to show you some things that are kind of interesting. Now, the reason that I'm using this software today is because I want to show you some of the different layers or images that we've gotten from different, from different spacecraft that we've sent there. So right now you can see the Messenger spacecraft, and this is the image that we see. But if we add some GIS data or some topographical data, we're able to see a lot more of the detail in the surface. Now, somebody asked, why is there a stripe right here? And that's just because the spacecraft that we've sent out there hasn't really gotten some hasn't gotten some data in that area. So it's not as high def as the rest of it. And that's a really fantastic question. So when we look at this topographical data, or the heights of this, we can actually see some interesting stuff. So when we look at this, blue is our low-lying areas. Now we talked about Maria on the moon, which we used to think were oceans of liquid water. Mercury has some low-lying areas like that as well. Like we have a giant crater right here. And it's hard to tell without that GIS data that it's so much lower than the rest of the surface. We think that a long time ago, a rather large object hit Mercury right in this area right here, and was able to make a giant crater that we're seeing right there. If we go around to some of the other areas, now blue is our low-lying area, and red is going to be our much, much higher areas. So you can kind of see the craters are a little bit different, but we also have right here a much, much higher area. So like I said, these are our topographical maps. And so we're able to see the different heights of the different areas. And we've got a huge area over here that's much, much higher than the rest of the surface. And we're still trying to figure out why something like that might exist. So as we go over, we can actually see that there's a lot of difference between the heights. There's a lot of different low-lying areas and some areas that I would probably call mountains on the surface as well. All right. And we also have right down over here, my favorite crater on the surface of Mercury. So I can actually bring up some of these labels for the different craters, because we have named them, similar to the fact that we've named craters on the surface of the moon. There we go. So this one right here is my favorite crater. We have Debussy, which is, like I said, my favorite crater on the surface. All right, so somebody in the chat mentioned that Venus is hotter than Mercury. And that's true. Venus is hotter than Mercury, even though it's further away from the sun. So Mercury, like we kind of said, is a very dry, hot, rocky place on one side, very cold, rocky place on the other side, very, very close to the sun. But we're going to, this time, actually head to Venus, the other planet that we'll be focusing on today. So let's go ahead and fly to Venus. Again, I apologize. It might be a little bit choppy while we're flying. We're using a software called OpenSpace, which takes a lot of my computer's memory as we fly over there. Now, here we have the planet Venus. Does this look like most of the images that you see when we look at Venus? Does this look like most of the images that we see when we look at Venus? What might look different from that? What might look a little bit different while we're looking at Venus right here? Does this look like some of the other images that we usually see? Does anybody have any ideas? Does this look different or the same? Different or the same? And this might help right here. If I bring up my little celestial buddy, does this look different or the same as most of the images that we see, or our celestial buddy right here? I see some people saying no. They're saying it's very red and very hot. And that's because this right here is actually Venus without an atmosphere. So when we take a look at our celestial buddy that I have right here, we can see that it's a very different color than we see in our virtual planetarium. And that's because we've actually gotten rid of the atmosphere on Venus. Now, the atmosphere is the air. It's redder, which is very, very true. We've gotten rid of the atmosphere or the air. Part of the reason we've gotten rid of the atmosphere or the air on Venus is because the atmosphere on Venus is very, very thick, unlike the atmosphere on Mercury. So the atmosphere on Venus is very, very thick, and it's full of something that we call greenhouse gases. So I'm going to go ahead and bring up a different share of our greenhouse gases so we can see them a little bit better and see a little bit better about what I'm talking about. So let's go ahead and bring up our greenhouse gases. And there we go. We have, this is actually the Earth, but greenhouse gases are gases that actually stop the heat from the heat from the sun from exiting our atmosphere. So the heat from the sun comes in, bounces off the surface of the Earth, the short wavelengths go back out, and the longer light wave radiation, like infrared, will bounce back to the surface and actually heat up the surface. So this right here is our greenhouse effect on Earth, but Venus has a much, much more intense greenhouse effect. It gets up to 900 degrees Fahrenheit on the surface of Venus. We've actually been able to send a few spacecraft out this way. We were able to send Mariner, but we were also able to send some probes down to the surface of Venus. Now, somebody asked if it has lava on the surface. At 900 degrees Fahrenheit, most of the surface is probably lava. And I apologize for my roommate. Sometimes she can be a little bit loud. So it does have lava on the surface of it, and it does have active volcanoes. But here we have Venus and the surface of it. So I said the surface can get up to 900 degrees Fahrenheit. And the atmosphere is actually made out of sulfuric acid. So when it rains on the surface, it actually rains acid rain or sulfuric acid down from the sky. So Venus is not a place I would particularly like to visit. But like I said, we have sent spacecraft to the surface of Venus. Those spacecraft have been able to go through the atmosphere, and even though that atmosphere is really, really thick and has a lot of pressure, those spacecraft were able to survive for about an hour. After an hour, those spacecraft were crushed like a tin can. And so those are now still down on the surface of Venus, but we're not able to get any more readings from them. The atmosphere, because it is so corrosive, will actually eat up the aluminum or the steel that we have on the spacecraft. And the atmosphere is so thick that it pushes down on that spacecraft to crush it like that aluminum can. So here we have our planet Venus, and somebody keeps asking, what are these white areas right here? These are probably the active volcanoes that we have on the surface of Venus. Now, somebody asked, how long could humans survive on there? Which is a fantastic question. The answer to that is not at all. Because that atmosphere is so very thick, it would push on our bodies and we wouldn't really be able to survive. If we could survive the intense pressure, even the intense heat of 900 degrees Fahrenheit, the sulfuric acid would not be great for us as we go through the atmosphere. And but if we could survive all of that, we could actually strap wings to our arms and fly, which I think is really cool because that atmosphere is so thick that we would be able to overcome gravity very, very easily. So we haven't been able to go down to the surface as human beings, but we have sent robots or probes down to the surface of Venus. So these are the two planets that we were planning on talking about today. Does anybody have any questions about these planets that we've been talking about? So we have Mercury and we had Venus. Mercury looks a lot like the moon, very, very close to the sun. And, but only about 600 degrees Fahrenheit, where Venus, further away from the sun, gets up to 900 degrees Fahrenheit. Someone asked if we could survive on Mercury. Again, really fantastic question if we could survive on Mercury. Remember, the daytime side gets to about 600 degrees Fahrenheit, and the nighttime side gets about to negative 200 degrees Fahrenheit. So if we were able to go onto the surface, we would have to find a very, very small area of that surface where we could survive because of the temperature. But it's a very, very small area. It also doesn't have any atmosphere, so we would have to bring our special gear, oxygen, all of that for us to be able to survive on the surface of Mercury. And somebody asked if any living things could survive on Venus. And you know what? I really like that question because the answer is we don't know. There are some really interesting living things that live at the very, very bottom of our oceans. So they live at the very, very bottom of our oceans, right next to these things that we call thermal vents. And those things are down there and they are able to survive. Now, they're not intelligent beings, but they are down there and they are still living things. So possibly we could have living things on Venus. We never know, especially because we can't get down to the surface for long enough to make proper measurements. Is it likely that there's life on the surface of Venus? Probably not. But it still is a possibility, not a probability, a possibility that it's there. So yep, those hydrothermal vents at the bottom of our oceans, where they're really, really hot, do have those organisms near them. All right, so any other questions? Ooh, that's a very good question. How old is Venus? So most of the planets in our solar system, so Kendra, thank you very much for your question. Most of the planets in our solar system were formed at around the same time. So essentially, a long time ago, we lived in this sort of big old cloud of stuff. And the sun started to form, and all of the planets in our solar system started to form at about the same time. So our Earth is about 4.5 million years old, or billion years old, million years old. And so it is about the same as that. So they all started to form at about the same time. So fantastic question. Could there be a planet that we never discovered that hit Mercury? Also a super fantastic question. So the answer is yes, there could have been a planet at some point that hit Mercury. In the formation of our solar system, there was all of this stuff sort of being all jumbled up and pushed together. So we'd never know if there at one point there was something there that hit Mercury. All of the planets actually formed by things colliding together. Yes, 4.5 billion years. So we could have had a planet at some point that hit Mercury, and we wouldn't know about it without doing some very interesting investigation work. All right, so do we have any other questions about these two planets? Something that I forgot to mention, the Venus is actually rotating backward on its axis. So instead of the sun rising in the east and setting in the west like it does here on the Earth, on Venus, the sun would rise in the west and set in the east. We think that a long time ago, something may have hit the surface of Venus and started it moving the other direction, that opposite direction. And so when it did that, so when it did that, the planet also slowed down significantly as it rotated on its axis. So a day on Venus is actually very, very long. All right. So do we have any other questions? Oh, we have a really great fun fact from Elijah that the Earth won't be here in 5 billion years because the sun is expanding, and when it gets too close to us, all the water will dry out and will burn up. So that is true, but don't worry, that's going to be in about 4.5 billion years. So that's not going to be any time soon. Let's see, we have a couple of other questions. We have somebody who asked, Chris asked on Facebook, is it possible that an asteroid hit another planet like Venus or Mercury and affected Earth's place in the solar system? Again, it is super possible. So the planets formed in a giant cloud, like I said, and things were going around jumbled up. And so at some point, we could have been impacted by some of these different objects in our solar system, like asteroids, and even other things that were like the size of some of the planets. So we think that our moon was actually discovered by, we think our moon was actually created by another object hitting the Earth and then creating the thing that we see. So somebody asked, how long is a day on Mercury? Like I said, it's 58 Earth days on Mercury. And it takes 88 days for it to orbit around the sun. And Venus is one day is 116 days. So very fantastic questions. We have one more on Zoom. We have Elise asking, why is the Earth the only planet that formed that humans can live on? You know, that's a really fantastic question and something that we really don't know the answer to. So if we sort of think about the planets in our solar system, we were able to see that some of them are really close to the sun and some of them are really far away. So let's go ahead and put the sun back at the center and zoom back out to see the rest of our solar system again. So if we take a look, we're just going to focus on the inner planets right now. We can see that Mercury is very, very close to the sun, so it's very, very hot. Venus is a little bit further away, but because of those greenhouse gases, we're not able to have, it gets very, very hot. We're not able to have life on that planet either. Mars is just a little bit too far away from the sun, so it's actually pretty cold on the surface of Mars. We'll get to Mars another time, but it's about even the hottest temperature on Mars is about 74 degrees Fahrenheit, so not very warm. But if we take a look at Earth, it's in something that we call the Goldilocks zone. It's not too far away from our sun, not too close. It's in that perfect area, and that perfect area is the Goldilocks zone where we can have life and liquid water. So we're the only planet in our solar system that we know of that has abundant amounts of liquid water, which is what we need for humans to live. Somebody asked, what if we transfer our greenhouse gases to Mercury? I really wish it were that simple. So because Mercury is so close to the sun, it actually can't hold on to an atmosphere because everything is so hot. So we've been sort of talking about on Echo Live our states of matter. So when you give more energy to something, that state moves faster and faster and faster. And because the surface of Mercury is so hot, we're not really able to hold on to very much gas because it gets thrown off from the surface. So it's a really great idea, and I wish it were possible, but unfortunately, not one of those things that is possible. So very great question. All right, so we'll wait for just a couple more questions, but Anna, let's talk a little bit about our sponsors.
Great idea. So as always, we want to take this moment to thank our sponsors. Like, I'm going to take over the screen share here. Like Ford and Denso, who allow us to bring our Echo Live programs to you at home every day at 2:30 p.m. Eastern. We are so appreciative to those of you who did donate to the Michigan Science Center on Tuesday in honor of Giving Tuesday Now. Your donations really do mean the world to us. We love bringing these programs to you, and we are hearing your suggestions. So fun fact for everybody, or special surprise, we have heard your request. We know you want a slime episode of Echo Live. So if you tune in tomorrow at 2:30 p.m. Eastern, we have a very special slime program planned. We'll talk all about slime, how to make it, how you can do it at home, and how the Michigan Science Center makes it while we're open to the public, so that maybe one day, once we do reopen, you are able to come make slime with us at the Science Center. So great idea. Thanks so much, Paula. Do you see any last questions that you want to get to before we head out today?
Someone asked if we would melt on Venus, and the answer is yes.
Absolutely. I do not want to visit Venus. It's not on my list of places to go. Maybe
Definitely
Mars
not.
one day.
Maybe.
Maybe. All right. Well, thank you so much for joining us, Paulette. Thank you, everyone who joined us for Echo Live. We hope we'll see you back here tomorrow at 2:30 for another really fun episode. And we'll see Paulette again next week to talk about Earth and Mars in our virtual planetarium. So see everyone later and have a great rest of your day.